Well, let's look at an application problem that may include a rational expression and how to solve that problem. The one that we're looking at right now is a distance equals a rate times time problem. So we're going to be given some information that determines or is given a distance, a rate, and or a time. Well, the scenario that we have right now is we're talking about a boat in still water. How fast does that boat go? Well, the problem tells us that the boat goes 8 miles an hour in still water. I also read in the problem, and I'm just telling you this information right now, I also find out that the boat can travel 15 miles downstream in the same amount of time that it travels 9 miles upstream. Seems like some useless information right now, but maybe it will help. And want to find out what's the current of the water. How fast is that water going? Well, I hope I have enough information to solve this problem. I don't want to guess. I want to use some of the skills that we've learned so far. So let me help you start to piece this together. The first thing I like to do is describe in a variable like x, what's the one piece of information I know nothing about. And basically I don't know anything about the current other than it's flowing. So I'm going to let x equal the rate of the current or the water. From there, I'm going to try to describe other elements in terms of x. For example, can I describe now how fast the boat is going downstream or how fast the boat is going upstream? Well, let's say it's going downstream or with the current. I would say that the boat's going 8 miles an hour plus the current. The current is helping it go faster. Going upstream, the boat can go 8 miles an hour in still water, and now it's fighting against the current, so I'm going to subtract the rate of the current out of that. The next part of this problem that will be helpful is one, if you recognize it was a distance, rate times times problem, what I like to do is draw a table, distance, rate, and time, then start to fill in some of the pieces of information. So let's say I'm going to talk about going downstream and going upstream, or the rate of the boat. The distance downstream problem tells me something about 15 miles downstream and 9 miles upstream. So I'm going to use that piece of information. We determined what the rate was. What's the rate of the boat going downstream? It's an 8 plus an x. And the rate of the boat going upstream is 8 minus x. And time. Well, I wasn't able to come up with anything that was told me specifically about time other than the fact that the time downstream is equal to the time upstream. So what do I put in this column? Well, if I remember that distance equals rate times time, I can solve that equation for time. Divide both sides by r. So I have distance over r equals time. And so in this column, I can go ahead and describe that. The time of the boat going downstream is its distance. It goes 15 miles every 8 plus x. And then the time of the boat going upstream is distance divided by rate, 9 over 8 minus x. I was able to find all the pieces of information, or what I think was missing. Now I'm going to go back and reread the problem and see, well, does the problem help me some more? And as I read it again, I remembered that again it told me about this 15 miles downstream equals 9 miles upstream. That's saying that this time equals that time. There's an equation right there. 15 over 8 plus x equals 9 over 8 minus x. And I can solve this equation. I'm going to find a number to multiply both sides by, 8 plus x over 8 minus x. Eight plus x is cancel, so I have a 15. 8 plus x equals a 9. 8 minus x is cancel, 8 plus x. All the fractions are gone, used a fraction killer. Now I can multiply. 15 times 8 is 120 plus 15x equals 72 plus 9x. I want to isolate x, so let's subtract 72 from both sides. I get a 48. Let's add a negative 15x to both sides. and, oops, sorry, there's a negative over here, guys. That's negative. Nope, this one's negative. So I have a negative 15x here. Let's add 15x to both sides. So that's going to give me positive 15x plus 9x gives me a 24x. And it looks like x equals 2. So I found out what x equals. No big deal. Well, it's a big deal if we remembered how did we start the problem. We started the problem by describing the rate of the current as an unknown, x. Well, now we know what that is. 2. The rate of the current is 2. So how fast is the boat going downstream? It's going 8 plus 2. It's going 10 miles an hour downstream. And then upstream, it's going 6 miles an hour. So that's one application of how we understand the relationship between distance, rate, and time, and how to apply that into a little bit of a problem that gives us some information, and then we use some of our skills on how to solve a rational equation to solve that problem.